Hello everyone, this is the Problem of the Week solution video for the problem Planina. The problem description goes as follows. Mirko and Slavko are filming a movie adaptation of the popular science fiction novel Chicks in Space 13. The script requires them to present a lot of different worlds, so they decided to film the entire movie in front of a green screen and add CGI backgrounds later. Mirko heard that the best way to generate artificial terrain is to use Midpoint Displacement algorithm. To start the algorithm, Mirko selects 4 points, forming a perfect square. He then performs the following steps. 1 on each side of the square, he adds a new point in the exact middle of the side. The height of this new point is the average height of the 2 points on that side. 2 in the exact center of the square, he adds a new point whose height is the average height of all 4 square vertices plus a small random value. After these 2 steps are performed, he now has 4 new squares. He performs the same steps on the newly created squares again and again until he is pleased with the results. And here they give figure 1, which shows the start and 2 iterations of the algorithm. Mirko noticed that some of the points belong to more than one square. In order to decrease memory consumption, he calculates and stores such points only once. He now wonders how many points in total will he need to store in memory after n iterations. As for our input, we should expect one line containing one integer, n between 1 and 15. And for our output, they want us to output one number, which is the number of points stored after n iterations. So for this problem, I'm going to ignore most of what's being said about it above. Looking at the start, first iteration, and second iteration, I see a pattern just within each of sides of the squares. Each subsequent figure has all of its legs broken into 2. This is what was being referred to as the midpoint displacement algorithm. This means that we can just construct a recursive equation out of just looking at one side of each of these squares. For each cycle, we can go through each of these individual legs and break them into 2 pieces. In each iteration, we are doubling the amount of points on each side minus 1, and that's because we are counting the points rather than the segments. In order to get the amount of points in the resulting grid, we then just have to square the amount of points on each side. Combined with our starting value of 2 points per side, we now have the total number of points expressed as a function of the number of iterations. So let's go to our example code and see how you could possibly implement it. So the first thing we do here is to get the iteration number from our input. Remember to cast the result from the input method to an integer, because the input method in Python returns a string by default. Then in line 3, we have this counter variable, which I call I. We start this at 2 because the initial value of how many points are on each side of the grid is 2. So here. So the next part of this code is this for loop, which is where the recursive equation we established early on is run. This for loop runs for n cycles, and inside that for loop we have our equation, and we just increment our counter variable by that. That equation is the same one that we got before, double the sides and subtract 1. Just note that I simplified this to I plus equals I minus 1. It's the same thing as doing I equals 2 times I minus 1. So just a different way of writing it. So if you did line 8 instead of line 7, that would be the exact same result. The last thing we need to do now that we have the number of points on each side of the grid calculated is just to print out the square of that value, which is what we do in line 11. And that should give us our result for the code. So let's try out our sample inputs. If we type out 1, it should return 9. If we type out 2, it should return 25. And if we type out 5, it should return 1089. And just for fun, the upper bound of our our iteration number that's given is 15. So let's try 15. That is a very big number. That looks like a billion, so that's a lot of points. All in all, we've established now that our code is functioning as we expected. So that'll be it for this solution video.